In this video, we will see the example problems from example 8.20. The question is, find the magnitude of A cross product with B, where vector A is given by this and vector B is given by this. So, we know that vector cross product with B vector, the formula is if A with B, if this is A1, A2 and A3, which are the coefficients of I cap, J cap and K cap, and you have B1, B2 and B3 as the coefficients of I cap, J cap and K cap, then your resultant A cross product with B is nothing but I cap, J cap, K cap, A1, A2, A3, B1, B2, B3. So here our A1 is 3, so you put a 3, our A2 is 4, and because the coefficient of K cap is 0, so it's a 0 here. Similarly, 1, 1 and 1. So B1 is 1, B2 is 1 and B3 is 1. So solving this further, the determinant, you get 4I cap minus 3J cap minus K cap. Further, the magnitude of A cross product with B is equal to the magnitude of this resultant vector here. So which is equal to square root of 4 squared, which is 16, minus 3 squared, which is 9, minus 1 squared, which is 1. So root of 16 plus 9 plus 1 is equal to square root of 26. So that's our answer. Question number 8.21. So vector A is defined by this vector and B is defined by this vector. Verify. The first question is that A vector and A cross product with B are perpendicular to each other. So we need to first find A cross product with B. So A cross product with B can be written as I cap, J cap, K cap, and the determinant, the coefficients of I cap, J cap and K cap of A and B. So further solving this, you get A cross B as 2 I cap minus 5, 51 J cap minus 30 K cap. So, for proving that A vector and A cross product with B vector are perpendicular to each other, if we show that A dot product with A cross product with A and B is equal to 0, then they are perpendicular. So, we need to prove that A dot product with A cross product with B is equal to 0. So, when we solve it, we get the answer as 0. Therefore, A and A cross product with B are perpendicular. Similarly, we need to find for B with A cross product with B to be perpendicular. So, applying the same method, B dot product with A cross product with B is equal to substituting the values of B and A cross product with B here and doing the dot product. So, 6 times 2 is 12, 2 times 51 minus 51 is 102, minus 3 times minus 30 is plus 30, so your answer is 0. Therefore, B and A cross product with B are perpendicular. Example 8.22. Find the vectors of magnitude 6, which is perpendicular to both vectors. So, we have vector A and B defined as this. So, to solve, we find the vector A cross product with B because this vector is perpendicular to both A and B vector. So when we solve this, we get our resultant as minus I cap plus 2J cap plus 2K cap. It's easy to solve the determinant here, so you get this result. Now, the unit vector perpendicular to both A and B are A cross product plus or minus A cross product with B divided by A cross product with B, its magnitude. So, substituting the values of each, you get this, and the magnitude of A cross product with B is 3, which is 1 square. Square root of 1 square plus 2 square plus 2 square will be root of 9, which will be 3. Now, the vector of magnitude 6 perpendicular to both A and B are plus or minus 2. That's by multiplying this by 6. 6 by 3 will be 6 divided by 3 will be 2 here. So you will get 2 times of this vector here, which is minus I cap plus 2J cap plus 2K cap. So that's the result. Example 8.23. Find the cosine and sine angle between the vectors A and B. To solve, so let theta be the angle between A and B. Then A dot product with B can be written as 12. Solving these two, we can get the answer as 12. And we can also find the magnitude of A as square root of 14 and magnitude of B as square root of 24. So our cos theta will be equal to A dot product with B divided by magnitude of A into magnitude of B. So substituting the values here, you get your result as square root of 3 by 7. Similarly, A cross product with B will be equal to the determinant matrix, which is equal to 8i cap plus 8j cap minus 8k cap. Therefore, the magnitude of A cross product with B will be written as 8 times square root of 3. Further, we know that sine theta is equal to the magnitude of A cross product with B divided by the magnitude of A into magnitude of B. Again, substituting the values of this and the magnitude of A and B into the formula, you get the result as 2 by root 7. Example 8.24. Find the area of the parallelogram whose adjacent sides are vector A and vector B. We know that the area of the parallelogram can be found when A and B are adjacent sides. A cross product with B is the area of the parallelogram with A and B as two adjacent sides. So let's find A cross product with B. So we get our A cross product with B as 5i cap plus j cap minus 4k cap using the determinant here. Now the magnitude of this is equal to the area of the parallelogram. So the magnitude of A cross product with B is equal to the magnitude of this vector, which will be square root of 25 plus 1 plus 16, which is root of 42. Therefore, the area of the parallelogram is root of 42 square units. Example 8.25. For any two vectors A and B, prove that the magnitude squared of A cross product with B plus the A dot product with B squared is equal to the A vector magnitude squared multiplied by B vector magnitude squared. So, to prove this, let's define our A cross product with B magnitude as just A magnitude into B magnitude into sine theta. Similarly, our A dot product with B is defined as magnitude of A magnitude of B into cos theta. Now squaring them both and adding them, we will get squaring them both and adding them. So you have to square this, which will be A squared magnitude square B vector magnitude square into sine square theta. Similarly, squaring this, our A vector magnitude square multiplied by B vector magnitude square into cos square theta. Now you can see that A square and B square are common. So if we take them out, you will get sine square theta plus cos square theta here. So we know sine square theta plus cos square theta is equal to 1. Therefore, our answer would be magnitude of A squared into magnitude of B squared. Hence the proof. Example 8.26. Find the area of a triangle having the points A, which is 1, 0, 0, and B, which is 0, 1, 0, and C, which is 0, 0, 1 as its vertices. So these are the vertices, and you're asked to find the area of the triangle. Now what we can do is, since you have points A, B, and C, and of course, it's from the origin, so you can define the vector AB here, and you can define a vector AC here. Now the magnitude of AB cross product with AC will be the area of the parallelogram with AB and AC as adjacent sides. So if I'm going to divide this as a half, then the area of this triangle would be the half the area of the parallelogram. So half of this would be the area of this triangle. So which is what we are going to find here. So let's proceed to solve the problem. So let us find two sides of the triangle, which is AB vector and AC vector. So with the information which is given to us, we can say that AB vector is equal to OB vector minus OA vector, and you can find the OB and OA vectors and OC vector using these coordinates. So your resultant AB vector will be minus I cap plus j cap, and AC vector would be minus I cap plus k cap. Now our AB cross product with AC will be equal to this determinant. So solving this determinant, you will get your answer as I cap plus j cap plus k cap. So the magnitude of this cross product is equal to square root of 1 squared plus 1 squared plus 1 squared, which is root of 3. And therefore the area of the triangle ABC is half of this magnitude of AB cross product with AC vector, which is equal to square root of 3 by 2, and that's our answer. Thank you for watching Math Tutorial Anand. Please like, and you can comment if you have any questions, and do not forget to subscribe to get more videos like this.